Okay, so we've got a little run of questions that are about basic vector quantity, so I've just lumped those together, questions 22, 23 and 24. Straightforward definition of vector quantity. A vector quantity has magnitude and direction. A scalar quantity, of course, has magnitude only. So we've got to be able to pick out vector quantities. So acceleration. Acceleration is different in a different direction. Acceleration upwards is different to an acceleration down. That means something. So yeah, you should know acceleration is a vector quantity. Speed is just a side. Okay, we have velocity, which if you like is a vector version of speed, but speed is just a size, is a scalar quantity. Time, we talk about forwards and backwards in time, but we're not really talking about different directions in space. Again, a scalar quantity. Displacement is absolutely a size and a direction. That's within the definition of a displacement. And weight, quite often they do this. You should know that forces in general are vector, therefore any example they give of forces are going to be vector. So straightforwardly, weight is the vector there. If we move on to 23, we're being asked to look at the similarity and difference between a distance and a displacement, and it's a fairly common question. Similarities and difference between scalar quantities and vector quantities. So there was one on the September test, as I remember it, and the similarity you could give for 23 was that both have magnitude, which would be kind of the generic answer to that, wouldn't it? This could be the answer you could have given for any pair of values which are one vector and one scalar. Similarity, both have magnitude. What a lot of people would pick up on is that they're both measured in meters or both measured in m. Either one of those would cover it fine. And then what's the difference between them? It's not enough to say one's a vector, one's a scalar, or to say that one has direction, one does not. You need to state which is which. So distance is a scalar or displacement is a vector. And you could phrase that either as distance is a scalar or distance does not have direction, or more likely perhaps displacement is a vector, displacement does have direction. Not a lot else to say on that one. And then somewhere down here is 24, single mark for picking out the scalar quantity, so very much the reverse question of 22b, picking out the scalar quantities. Again, we've got weight here sitting there as an example of a force. All forces are vector. We've got velocity sitting there as the vector, if you like, the vector version of speed. Acceleration is a vector quantity. As we said before, number two scalars are density and volume. So that was G481 homework booklet questions 22, 23 and 24.